Okay, Roger once again, Mud Fossil University, speaking about this fabulous new technology that's been developed by the Chinese, been developed by this guy, Ole Morten Olesen, and it involves mud fossil technology. And literally, they are putting the soil system back together by using the clays, which I understand the system now, and I would like to help as whatever I can. I have no interest in any other thing than to help. And they can turn desert like this into productive farmland just like that. This is like 6 months after it was like this. Absolutely phenomenal what they're doing with it, because it creates a literal perfect system. The soil becomes back to a system. All right, you can't just have one of this and one of that, or throw a little of that on, throw it. You have to create a system, and this is what I think is capable of doing. But how do you get the water here? And I have an idea for that. So I'm just going to show what I have to show, and who knows, it may help, it may not, but I'm doing what I can. That's all. You know what I used to say? I'm doing the best I can with what I got. All right, this is just suggestions, and at this point, 100% guesses. Everything I've been telling you, some of it I'm pretty solid on, but and they know that it does grow fabulously in the desert now using these techniques. But how are you going to get that water? Well, there's a lot of it's near oceans. Oceans obviously have seawater, and that salty water, you can't drink it. But that doesn't mean the plants can't use it. They probably can't use it in its raw form. However, there's some ways of centrifugally throwing out a lot of the heavier molecules, and that might be some of the salts. There might be some way of attaching something to the salty molecules, and what they come in when they come in, to make them heavier, to throw them out, because water is a very light I mean, it's not light necessarily. It's a dense molecule, but it's a small molecule. Let's put it that way. It has only 2 hydrogens and an oxygen. Anyway, I'm not going to get too deep into chemistry. Just consider it this way: you're throwing all the big stuff out of there and trying to leave the little stuff, which the little stuff is the water. And I'm hoping that it should get rid of some of it. Let me put it that way. Now, water's polar. Salts are polar. What does that mean? You can put an electric current here and there, and push molecules to one side, pull them to the other side, whatever, to try. There are ways of doing things, and I'm just throwing out guesses, just ideas. That's all this is, because I'm not going to be involved in this myself, and I'm just really butting in. I probably don't belong butting in here, but I do have some understanding of how this chemistry works based on the mud fossils. So I'm not trying to take over anything. I'm just trying to show things. Anyway, and then and light has a big factor to things too, because people don't understand. Light is nothing more than electrons. We're throwing electrons in there, and electrons are heavily involved in these cations, in these molecular handshakes of transition metals, and of which are a lot of the things that are in the waters. And they are lightly held by electrical pulses, so electrical charges. So anyway, getting back to what we need is a water source that is not heavily salinated, or is not heavily polluted, or whatever you want to call it. But I don't think it's got to be anywhere near what you'd need for human consumption. So Saudi's using 25% of their oil production just to make water. I looked at the process, and it is very complicated. So this might be a whole new thing. Now, if you could get water into there, and then the castor oil grows, the castor oil's got the acids go back into the soils, the soil gets regenerated into much better conditions based on the fact that it's replacing the salts with acids. So everything works, let me put it that way, if you can get this water moving for a reasonable financial cost. And sooner or later, it won't matter what the financial cost is, because there's no more water. The water is going to be gone. So I would say get on this thing pretty damn quick. And the other thing you could do, I never thought why they don't do this, is take and wrap big icebergs with plastic or something, some kind of a membrane around them, and attach a blimp to them or something, and let it drift down here. Somehow let them float down here, and then pump it off. Anyway, there's going to some. This is a serious problem. This desertification. One, they're trying to address that, which they are with their that new technology they developed. You know, I mean, I'm talking about developing things. I have developed nothing. I am nobody in this. I am just, you know, I jump into things I know, and I sound like I'm taking over. I don't want to take over. I don't want to have anything to do with it other than I'd like to see it successful, and this is my 2 cents. All right. Anyway, that's Mud Fossil University, and other thing is you should use this stuff is great. This castor oil for aches and pains in joints, because I think what it does is the esters, and what you have to do is you put it on there, and then you put a little plastic wrap around it, and stay on there for a couple hours, and do that 2-3 days in a row, and it's been very successful for me and just about everybody that's done it. So anyway, that's a little Dr. Roger for today. So Mud Fossil University, thank you all, good luck, and I hope this works, and it would be fabulous to see this happen. So good luck to all. Alright, I was going to get into the chemistry deep, but I don't think I will. This is silo.br, and it's about castor bean production in soil irrigated with water containing different salty compositions, cations they call them. Now, just very briefly, so I seem to get caught up and I can't help myself, but it goes through a whole batch of different scenarios about S1, 2, 3, 4, 5, 6. Those are different types of cations, which are salts, in the waters that they're irrigating plants with. And then they go on how they exchange and don't exchange, and percentages and amounts and characteristics and salinity levels, and it's extremely detailed, and most people won't be interested. And there's a lot of conclusions on here. And you can go in here and look at it. But my point is that we're talking about castor oil beans. You see this? Castor oil beans. Irrigated with water in different salt solutions, really, is what that boils down to. Now, I'll tell you why that's important. All right. Again, we just saw that they were looking how the castor oil grew in different salinities. Well, why is that important? Because that's salt. Salinity is salt. And still, why is that important? Because castor oil is an ester, which is an acid. You see this? Average composition of castor oil seeds, they're a fatty acid. That's exactly what we need to put back into the soils. Acid, 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 acid. It's all acids. I mean, what can I say? This is what we need back into the soil. So here we got castor oil. They're looking into how it grows in salts. So there's some research there. There's nothing, we don't have to start from scratch there. Then we know that the acids are produced by those same castor oil plants that are invasive in some areas. You know, if they invaded the desert, I don't know if that would be the worst thing. And then we need to talk about the water. The water is the key. Now, all right, there's a couple things I had in mind here. This is from Fence Kid, and it's they're different Fresnel lenses. These are the lenses they had in the old projection TVs, and they take them out and they use them to focus the sunlight. And I mean, when I'm talking focus, wow! And you see, it'll burn. Look at this, 350 or so. Here we go. Watch this. He's up here and
glass bowl. And that's about the size of a Frisbee. That will cook awesome. Now, let me show you a spot lens. I saved this one for last. Look at this puppy right here. This one's gonna rock you.
Here, I just want to say something. They all look the same, but they're not the same. They have the way they channel the grooves in them. A Fresnel lens has all kinds of grooves in the surface, and it ends up focusing the light into either like a area or a pinpoint. He's going into a pinpoint right now. Here we go. And my point being is that you can use these Fresnel lenses and so forth, and some kind of just harvesting the sun to steam generators or something. Where do you see this thing? These things have got some serious power. And I also have something else that I will show you that we can accelerate light, and I have done that. And I would think if you put this through a light accelerator, you could maybe even create fusion or something, because it is, well, I'll show you, well, here, I'll show you that now, and then we'll go from there. And I'll show you what this guy's like. All right, this was from some experiments I did with Rodney Warren in Australia, and this is a single pulse red laser, just floating through space by itself, nice. This is ether. There are ether particles in space, and they polarize when powerful light passes through them. Now, watch this. We took this and put it through 2 round cylinders, just like this, 2 cylinders, just like that, and the light went through it, and here's what happened. Where are we? Here we go. Bang, you see that? This over here are the 2 cylinders. And the light is sucked through there like, well, it's excited to extreme explosion here. Now, just think about these lights that I'm going to show you in a second coming through an orifice like that, what you would get on the other side. And coming on the other side, absolutely amazing. I'll show you a couple other quick shots here. Where's the... All right, this is what it looks like when it comes. You're looking right into that accelerator. You can see these particles coming out of there. Absolutely phenomenal. And you see these little dots here? Look, look. You see these little dots all on these circles? Those are the actual ether particles polarized in the pattern of a magnetic field surrounding these particles. That's the magnetic field. These are literally electricity in air. First time it's ever been photographed. And this has never ever been even conceived. These are those same discs, only one of them, look, I'll show you. I'm very proud of this, that's why. Rod and I did a lot of work on this. You see that little red, that little white one there? You see that one? That baby has got some serious power compared to the rest of them. And when it hit one of those other discs, this is what happened. And that's light. Those are light particles. That's a light particle. That's a light particle. It's in the center probably, and this is the polarized ether around. But that is an extremely energetic one. When it hit this field and this particle, it created its own new field and particle, and it ejected a mini particle and field. And that could be the neutrino effect they're talking about, because these are electrons, literally. These are the smallest particles it's supposed to be that exist. Only we're seeing the field around, and we're not seeing the actual particle. The particle is like unseen, but the field that surrounds the particle has been illuminated in such a way. Rodney has techniques that you would not believe. And, well, anyway, I believe it because I know it. Anyway, let's go back to this other thing, because we need water in the desert. I'm sorry, I get carried away on these things. But anyway, here we go. We're back into to this guy with the lenses. Now watch what he's got here. So don't forget, we need to create a steam generator or something to run the power to pump the water. I mean, why not use it? You're out in the desert. You know, why not? So here it goes.
Watch this. Bam! I mean, that's like Luke Skywalker lightsaber.
Hold on, let me
right
get back
there.
there.
Right here.
Watch
this one's going to rock you. Watch this. Watch this.
He's focusing it down.
Bam!
Boom.
I mean, that's like Luke Skywalker lightsaber.
Watch, he could
right
go.
There. Insta. Woohoo! That melts pennies in 20 seconds. You'll melt liquid. So this lens can do everything that the other ones can, but it concentrates all of that. Watch it. Whoa, whoa, bam!
As soon as you hit the focal
you can draw
point,
with it.
you see this? This is some
You know
power.
what I'm saying? Cut a hot dog in half instantly.
Now, if you took that, I mean, look at that thing. if you took that and put it into our accelerator, I don't know what you'd get out of it. I wouldn't want to be there, to be honest with you. Look at that thing. And these new cameras are amazing. These 10, 12, 15 megapixel cameras, they have some kind of, they can see things that never were seen before. Anyway, I told you I get carried away, but that's the thing. You can use, there's so much sitting there in that desert, and so much potential, and there's jobs, there's futures, there's hope. Really is what it boils down to, because some people are desperate situations. So if this could help, I certainly would feel good about it. All right, so God bless you all, my friends.